Okay, welcome back to Digital Marketing from the Coalface, and I have a new partner in crime, and that's Stuart Harrison. Could you tell us, give us a potted history? But bear in mind, if anyone's interested, we did do an interview with you, Stu, a few years ago on one of the earlier episodes of Digital Marketing from the Coalface. So you can always go and have a listen to that. But yeah, I mean, potted history of how you finished up working for a totty-wee digital marketing agency in North East Scotland.
I started life off as a physicist for my sins. Haven't practiced that for about 30 years in anger. Early years were in the nuclear industry. I worked for some of the big asset owners, worked in technical jobs, moved around a bit as you could with big companies. So I worked in PR, worked in commercial, worked in HR to learn how not to manage people. Then ended up in a project management role. Got a bit sick of working for the big boys because it took too long to get a lot of things done. So I moved into the supply chain and really spent 20 years growing engineering companies. I ended up in business development, and that's where the fit really comes with Red Evo, because as a BD director, which I was for a long time, I used to buy in marketing services. I used to have marketing people working for me, but my focus was always on sales. So marketing was almost the second thought. It was the poor relation, really. Mm-hmm. And, having worked with you guys and got to know you and got under the skin of marketing, and particularly digital marketing, suddenly it was a bit of an epiphany about you can actually sell services and complex solutions online, and more people are looking to buy them. So that's what kind of floated in my boat, really, and got me interested.
Mm-hmm. Okay. And you are at the moment also on secondment. I don't know how much you can talk about that, or not at all, probably.
I talked a little bit about it. It's on LinkedIn. So, I picked up a sort of part-time contract. I'm working with the UKAEA. And for those who don't like acronyms, that's the United Kingdom Atomic Energy Authority. So I'm supporting them out of their operation down in Culham in Oxfordshire on a programme to try and get the UK supply chain ready for fusion possibilities in the future. So that's, commercial contracts. And I'm working with them on industrial engagement. So how can we deliver benefit to the supply chain so that UK PLC can win some work?
Mm-hmm. Okay. So hopefully it's clear from listening to Stu's generously potted history of where he's come from and finished up working with us, that it's a very good fit for us, given our focus on tech and industrial businesses. Just going back to your nuclear stuff, it must be interesting working in an industry that's named after a bomb.
Well, I would say it's explosive, but that would be a bad pun.
I wasn't expecting a mildly humorous comeback there. Well done. I guess what I'm driving at is, because, we're all about telling stories. We're all about helping businesses tell a great story, and that helps to engage people, attract customers, and all the rest of it. And, the nuclear industry, I think it's fair to say, has originally got its story wrong. I mean, Rory Sutherland, that nuclear bomb thing. I mean, Rory Sutherland said, the problem with the nuclear industry is it's incredible that, what nuclear power can provide in terms of clean energy, etc., is mind blowing. And its biggest problem has been the story it told started with, we've named ourselves after a bomb. And, it's like suddenly it's like nuclear energy, but wait a minute, nuclear means bomb. So nuclear energy can't be good. So nuclear energy, generally speaking, has probably got its story wrong. And it's encouraging now to see this resurgence in interest because it's clean energy, and resurgence in nuclear. It must be interesting for you because you probably started your life working in nuclear in the wake of Chernobyl and in a kind of atmosphere of fear and we need to get rid of this nuclear industry because it's such a bad thing because of the waste and everything else. And then you're now seeing it as it emerges as clean energy. Would that be fair to say?
Yeah, absolutely. I mean, it's been really interesting to watch the two things, the public perception and how it's presented as an industry. I mean, to be fair, for 30 or 40 years, the production of energy and the production of weapons were absolutely intertwined, So Rory Sutherland's comment about it, they named it after a bomb. Well, the early reactors were designed to produce material that could be used in bombs. So that's where it came from. But I worked in PR briefly in the 90s in nuclear. It became apparent quickly to us we couldn't change the public perception about nuclear, but we could change the public perception about our company within nuclear.
Yeah.
So whilst nuclear as an industry might have a bad reputation, especially after the likes of Chernobyl, the company I worked for could have a good reputation as a safe pair of hands, etc., within that industry. So we deliberately repositioned the messaging and the storying about our safety record, our track record in the environment, all of those kind of things, to a degree disassociate ourselves with the brand of the nuclear industry.
Yeah.
I mean, it was interesting going back to your comment earlier about some of the stuff I've done, because I've done a hell of a lot of report writing, as you would imagine. I've done an awful lot of proposal and bid writing over the years as well, and communicating the message that we do with the digital marketing is completely different to that. It's a very different style of writing, actually, which is I'm having to adjust to and be accustomed to, and it takes me back in many ways more to the stuff that I did when I was in PR than anything I've done in sales. Absolutely. So, but it's interesting because working in fusion now, which for those that don't know, fission and fusion, whilst they from a science point of view both come from atoms, it's completely different science. The potential impacts are very different. The waste that comes out of these two things is very different, but it's too easy to lump them together as it's just nuclear.
So we're working with engineering companies, and certainly some of our clients who are in the oil and gas industry. Some of them, not all of them, some of them are kind of busy trying to, appear or communicate that they are conscious of their carbon footprint and their, I guess being unkind, you could say some of them are trying to greenwash in order to survive. What's similar is there anything similar in the nuclear industry? I mean, the nuclear industry seems to have missed a trick with its storytelling around the fact that it's a very efficient and very clean form of electricity if you conveniently forget about the shit that's left over once they have to put new fuel into the reactor.
I think there's a couple of things there, and this is where it does get complicated. When you say the carbon footprint of something, it depends what you're comparing. So the big reactor that's being built at Hinkley at the moment in the UK, or 2 units actually, it uses a huge amount of concrete. Yeah. And anybody who understands environmental impact knows concrete's one of the worst things. So they're not. There's no technology is clean, and I think.
Is Hinkley using more concrete than all the wind farms in the UK? I doubt it.
Don't know. I wouldn't have thought so.
No, because the concrete that goes into the base of a wind farm is vast, isn't it? Yeah, and I'm not against wind farms. I'm a windmill lover. I'm not saying I am. I'm just trying to say, if we're saying that nuclear is not as green as you think it is because of the infrastructure around the guts of it, then I think you could level that criticism at all energy types.
Yeah, I mean, the one thing that amazes a lot of people is how much nuclear fuel you actually need to power an individual's lifetime, assuming an average individual driving average miles, taking average flights.
Yeah, I mean, you communicated this recently. Go on, tell us.
Yeah, so the amount of fuel you actually need would fit in a Coke can.
To power like my entire life, all of my energy requirements for my whole life.
Correct. Yeah. So... Yeah. I mean, it's a very small amount of fuel. And if you actually look at the size, if anybody's seen a nuclear reactor in real life from the outside, it looks a huge building. The actual reactor vessel is tiny inside. Yeah. The rest of it's all shielding, protection, heating systems, cooling systems, electricity systems that just fit on the outside of it, Yeah. Okay. So, but what people fear the most is the consequences. If you don't understand it, the consequences are unknown. And people who don't understand the science behind it are understandably, as we all are, afraid of it. They don't necessarily realise by living in Cornwall or Aberdeen, you're actually getting a quite a significant radiation dose every year because it comes from the rocks. Yeah. Your own bones emit radiation. It's all about context and understanding, really. But from a power production point of view, I mean, it may have changed now because wind turbines have become more efficient. But at one point, to have a wind farm that would produce as much power as one of these new nuclear plants, it would need to be about the size of Birmingham. So a major city, yeah. And so it's the scale that's the issue, really. Is how much power these things can produce. Although the big buildings, it's on one footprint. It's not spread over miles and miles and miles. That said, this is where, alternative forms of energy, like wind, like solar, like wave, etc., where they can outperform is they can innovate very quickly. So nuclear, to be safe, as you would expect, has got a huge amount of codes, standards, safety regs, etc.
Yeah.
And before anybody will change those, you've got to do 10 years worth of research to and I'm not joking about 10 years. It's about 10 years of research to get one of those codes changed. Whereas if you want to change the angle of a blade on a wind turbine because you think it might make it more efficient, you tell Bob back at the factory and he makes you a slightly different shape. Yeah.
So, I think that's something that's missed. I mean, we will get off nuclear in a second, but that's something that's missed. And I'm picking up on something that you said when we were talking about, I think it was in relation to when we were brainstorming around the rebranding of the nuclear engineering company that we're now working with. It was something like, the chances of that happening are like 1,000 to 1. So it's like, there's no chance of that's going to happen. But you said in the nuclear industry, the chances of something happening being 1,000 to 1 means, we can't do that then. Totally unacceptable. Yeah, so the standards that the nuclear industry works to are quite incredible, aren't they?
Yeah, they are. And, to make it real and maybe a little bit personal, but I had to, as you know, go to the hospital for a procedure, one that's considered relatively routine. And the NHS had given me some really useful information about what the procedure's going to be. And they said, there's a 1 in 15,000 chance that we might tear something when we do this. And that might need major surgery. And there's a 1 in, I think it was either 25 or 30,000 chance you might die. Having come from the nuclear industry, when we're looking at safety cases, we consider things that might be 1 in 10 million and put mitigation in place. And so I saw the consultant and I went, is this supposed to make me feel safe? And she said, well, 2 things. One, we have to publish this data, because in case we get sued. And I went, fine. And she said, the other thing, it's meant to make you feel safe. And I said, well, I would say that 1 in 15,000 chance of major surgery as a result of this wasn't good odds. I mean, great if I'm going to the bookies and I'm putting a quid on a horse at the Grand National. Fantastic. It is a long shot. I get that. But, I've made more than 15,000 journeys in a car in my lifetime, probably in the last 3 years, really. And if you're going to have major surgery every time you drove 15,000 miles, you wouldn't accept it, would you?
No, that's right. You wouldn't.
I'm going to get in my car and this seat's really uncomfortable. So if you do 15,000 miles, there's a good chance you're going to have major back surgery because, but we're not changing the seat design. So it is all about perception. It's all about, and numbers in particular, numbers are meaningless unless they've got context.
We are working with a new client in the nuclear industry, which we're delighted about. We're working on a rebrand and you and I have had sight of the initial rebrand work we've been doing for them. As part of that, because we were working with them, and I just I'm interested anyway. So as you know, and I related it to you because I said, look, I've been doing some research, Stuart, and I've kind of figured out, I think, how nuclear reactors work. And I explained it to you and you sort of like patted me on the head and said, that's kind of, more or less that's how they work, Dave. Now bugger off back and do some more marketing. So do you
want my response to that?
Yeah, go on.
So in the same way you describe a car with 4 wheels, a steering wheel and an engine and you put petrol in it, it's absolutely correct, but it's missing some of the detail.
All right, I didn't talk about the indicators. Christ almighty, you can't please some people. But what was interesting for me at a very superficial level, I kind of thought, so basically we've got organized chaos. And there's these things called control rods, and they kind of keep the organized chaos from getting out of hand, and it creates enormous amounts of power. So I kind of got that. That was the whole nuclear fission. Right. Yeah. Okay. So why is nuclear fusion so hard? I mean, I didn't actually think we'd get talking about nuclear fusion in our first Digital Marketing from the Coalface podcast together. But I'm very interested by it because obviously energy is a really hot topic for all of us. So what is it? What's the difference? What's the big difference with fusion?
Okay. By the way, listeners, tune in for next week's episode on quantum mechanics.
where we will both talk about and not talk about quantum mechanics.
Very good.
Sorry.
Very simply, fission is where you split a big atom into smaller atoms and it releases energy.
Yeah.
Fusion is where you combine two very small atoms and it releases energy. And everything else is very different. How you produce that, how you control it. So in fission, it's metallic fuel basically sitting stationary, and as you say, you use control rods to control the rate of reaction that's going on. In fusion, basically, this thing gets so hot it turns everything into a plasma, which is it's more than a gas. It's literally everything's just it's a vapor. It's more than just a vapor. It's really hard to describe.
It seems very hard to describe because you can't describe it.
So the best example I can give you of a fusion reactor, a natural one, is the sun. That is a fusion reactor.
Okay. Right. So for fusion is effectively trying to recreate mini suns here on Earth in order to create power.
Yeah. Very mini suns, so a few atoms, not like billions of
atoms. And something that's only the size of a few atoms can produce enough energy to produce meaningful amounts of power.
Yeah, and to give you an example,
please do.
And this always blows me away. The most common current design of a fusion reactor is donut shaped. So you create the plasma and control it with magnets, and then you extract the heat. So the outside edge of that donut is near as damn it absolute zero. So that's minus 273 degrees C for those that don't know. Or Kelvin.
0 degrees Kelvin.
Yes, 0 Kelvin, minus 273. Well done. The plasma is 100 million degrees centigrade. Yeah, can't get my head around that.
That's even hotter than my nana's hot pot.
Exactly.
That was capable of generating electricity, my nana's hot pot. How she made it so hot, I have no idea, but she did. Bless her.
And the challenge in all of that, they've created fusion, they've created plasmas, they've created them in bursts, but the challenge is now an engineering challenge in many ways. So the science is proven, the science exists. It exists on a reasonable scale, not an industrial scale, but still like the one of the donuts in the UK, the tokamak as they're called properly. It's probably about 20, 30 feet across, something like that, 3 or 4 meters. To make power on an industrial scale, you need something 10 times, 20 times that size, the same as you do with any other power station. So the hard bit is controlling the plasma. The next hard bit is how do you take the heat out without losing control of the plasma or losing the plasma and then transfer it into a heat system that would be similar to that of a conventional power station, to pump it into water to turn to steam to feed a turbine.
Yeah. And is anybody producing electricity from fusion on an industrial scale anywhere in the world yet?
No. And
aren't the Chinese very close to it? Or is that just bullshit that I've seen on Twitter or somewhere, or not Twitter, TikTok?
Yeah, they've got some really advanced experiments. I think it's fair to say until about 10 years ago, there was probably only 4 or 5 large-scale experiments in the world, the UK being one of the leaders in it. And more recently, and the joke in fusion was industrial scale fusion is always 50 years away, but it always has been 50 years away.
Okay.
So, but what's happened more recently, there's been a lot of private money coming in rather than just government funded research projects. There's private money coming in. So, some of the big hedge funds, some of the wealthy, people like, I think Bill Gates, don't quote me on that. You might have to edit that out, but, is backing private power companies to produce power to the grid. So most of the experiments to date have been exactly that. It's been R&D projects, and as you'll appreciate from your background, delivering an R&D project is not the same as delivering an industrial project. You've got a very simple aim with an industrial project: make it big enough, make it work, and build it on time to budget. Whereas with R&D, the primary purpose is let's experiment,
let's see if it works. Yeah.
Yeah, and what happens if we turn it left rather than right? It's that kind of thing.
Okay.
So we can learn more about it. So there is some good stuff. If anybody is really interested, and I suspect they're not if they're listening, but there's an international organisation called the Fusion Industry Association, funnily enough, and they've actually got a brochure you can download that says who are all the developers at the moment and where are they up to.
Yeah.
But there's about there's several billion a year being spent on it now. Yeah. It's not small scale, some mad scientist in a shed. Yeah.